Alright, welcome to another draft physics presentation. Mostly a supplementary to the Professor Lewin recontextualized videos of his lectures, and on the subject of electromagnetism. I'm asserting that there's only one force. There's not an electric force and a magnetic force. And I want to attempt to clarify, make it clear, as clear as I can, how I know that to be true, what phenomenon makes it obvious or makes it deducible, how it works. And it does have a lot of implications, because the conventional notion of photons is that they're somehow a thing moving through fields, and that they have an electric function and a magnetic function of waves. And I would assert you can't come up with these two fields. There's just one force, and it can't be doing both things. It's causing both effects in matter, but it's not traveling through space as two different kinds of force. Travels through space as one change in the force that exists in space. So I don't want to go too deep into the rest of the story, but the basic rest of the story, the history is that gravity is the only force. There's force bits in the universe, stuff moving the speed of light, very small. And these bits have two types, two polarizations. Red, black, you can just north, south in the case of magnets, some notion of positive and negative. And we use negative to denote electron, so the negative would be the electron force, the positive would be the proton force. And as stated, it's just a quanta of energy that moves the speed of light, a little bit of force. And it just moves in straight lines, and it bangs into electrons and protons, and that's what makes the universe, because the electrons and protons, as this diagram sort of attempts to illustrate, react to the two kinds of force inversely. So if electron force, the black force, hits an electron, it reflects, causes the electron to move a little. If the red force hits an electron, it leaves in some perpendicular dimension. Likewise for the proton, if it's hit by red force, it reflects, and if red force hits it, it leaves perpendicularly. If red force hits it, it reflects, and if black force, electron force, hits it, it leaves perpendicularly. So through this mechanism, you can eliminate the possibility of force. Say if between an electron and proton, no force can get trapped between them. So with two electrons, if a black bit of force gets trapped between them, it'll stay there and keep bouncing and reflecting and causing energy. And the closer you bring them together, the more energy, the more vibrations. And I would argue that between electrons is where photons are created. So the further apart the electrons are, the longer the wavelength of photon, the closer together they are, the smaller the wavelength, like X-rays and such. The protons are doing the same thing, but because they're trapped in a tiny nucleus, you don't have much effect. And that's sort of the nuclear force is sort of explained by the fact that the protons have an equal number of neutrons, and the neutrons are basically a proton and an electron, which is exactly the kind of mechanism you need to bring two things together. So if we want to bring two electrons closer together, you need to do something to interrupt the trapped energy, and the proton serves that purpose. So if you have a proton between two electrons, all the black force leaves through the electron, and oh, I'm saying it wrong, right? All the red force, well, there are two electrons and it's a proton, right? So the black force leaves through the proton, and the red force leaves through the perpendicular through the electrons. So no force can get trapped between them, and they'll move a lot closer together. So the strong nuclear force really isn't a strong force, it's the absence of force. It's a low pressure being created by excreting the force. So through that mechanism, you can create all kinds of complex relationships based on pressure, just based on the fact that there's more pressure on the outside pushing things together and less pressure inside pushing them apart. And that's the whole function of all of the stability in atoms, all systems, solar systems. Everything is sort of based on pressure and changes in pressure. Alright, so the atom itself, as I've attempted to illustrate and argue, so we'll go to the drawing, I suppose. And kind of gray, but close enough. It should be usefully or enough of enough contrast it'll do. So an atom would have, let's put the proton in the center, the protons, and the idea is that that would be the positive energy, and the positive matter bit, and then the correlate to that is the electron, the negative. And in the case of most complex elements, there's more than one electron, and the electrons are at a distance, normally at a distance, that if you were to look at this atom from a distance, it would look neutral. So the idea is that even though the protons have more force, they're capable of radiating, technically, and electrons are smaller in terms of how much force they have, the electrons are closer, and so it ends up equalizing. So even the protons are bigger, at the right distance they look the same, and that's about all that matters, is how you look. And so at a distance, that sameness goes, once you've established a neutrality point, that's how it's going to look from anywhere else you go out, so to speak. So in a sense, the electron provides a screen against the strength of the red force, you could almost argue. And so it's neutral, even though it's technically not. If if the forces were put in the same position, it wouldn't be. But it's more, like I said, it has more to do with the optical effect is more to do with almost a blocking. So the proton is a size and the electron is a size kind of thing, and there's a point where the two would block one would block out the other, and so then it would look all black because this is getting blocked. And so in a way, I think that's more important to this argument than this is also important, but it's a combination of the two, but it doesn't matter. Just understand that what this thing looks like changes in terms of what you sense it is from different positions. So if you're close enough to the electron, you don't see the proton, is sort of the argument. And it just looks like an electron. It just looks like, you know, there is no proton. And so in atoms, what can happen is there's the common state, what we call like the ground state of atoms, would be a condition where this thing looks balanced. That is, the electron is blocking at this point, it would be radiating. So this is where the important part. This atom in its neutral state will be radiating just as much red energy as black energy. So there would be a 50-50 relationship. 50% of the force coming from the atom would be red, and 50% of the force would be brown. So there's a certain relationship of electrons to proton and distance that the world will get 50%, 50%. So the electrons are blocking the sun, so to speak. So if you thought of the Earth as a much bigger planet, and it would block half the sun from a distance, percentage-wise. So the sun's energy would only be half as much because the Earth was always absorbing half of it. So that's a neutral atom. So what can happen to atoms is that you can compress them, that is, push them closer to each other. And when you do that, didn't really draw it to scale at all here, but it'll do. So let's just imagine these are half the distance that these are. So these are closer to the proton. So this is the, we'll just draw the circle smaller so you get the idea. So you've compressed the electrons into a smaller orbit. And by doing that, you can sort of logically understand that if I take this big thing that was blocking 50% of the sun's light and I bring it even closer to the sun, that now it's going to be blocking a lot more than 50. So this atom would be radiating something like 70% brown force and only 30% red. And we'd call that charged. We'd call that a negatively charged object because it's, you know, I won't draw the radiating lines. I think you're adult enough to get it. Then the opposite scenario would be something positively charged, where the circumference gets much bigger for the electrons. And so now you got numbers like, you know, 70% for the red force. The sun gets through 70% of the time, and the electron, the negative force, only gets excreted 30%. And so that's essentially the creation of these charged objects essentially duplicate the electron and the proton themselves. They become something that is essentially an object that you could, if you were to hit this object, since it's primarily now a proton object, it would reflect the force 70% of the time if I hit it with red force. And likewise for this electron object. So, you know, this has essentially become a big electron. Yeah, wrong one. This is the big electron. The small becomes the big electron, the compressed one, and the relaxed one becomes the proton, just like a proton. And they'll behave just like a proton in the sense that they're magnetic, they're charge monopoles. They're monopoles of magnetism. So magnetism is just basically having one of these high pressure atoms next to a low pressure atom, and that would be a dipole. So if you can create something where you know, I'm just trying to think of, I just want to make sure my colors are, so the expanded atom is proton heavy, the compressed atom is electron heavy, and so if you put two of them next to each other, you'd basically be creating a standard magnet. And if you put a bunch of magnets together, you know, that will create a stronger and stronger magnet, as is illustrated in the real world every day. So these are the forms that this that atoms take, that are the things that are receiving and producing the force that we call electromagnetism. So the force is just this stuff moving the speed of light. And whether or not it's magnetic is depending on whether it's got a dipole. That's really magnetism. And if you want to say whether it's charged, charge is really just the monopoles of the magnetism. It's just separating these poles, and that's essentially what charge is. So charge is just a rudimentary form of magnetism. And It's like being able to separate the poles off of a magnet, the red end and the black end, and have them stay all red or all black, instead of converting into magnets, littler magnets, smaller magnets. You can't cut a traditional magnet because it's a bunch of little magnets and it just reverts into another dipole. So, yeah, so these words, dipole and monopole and charge, they're all really important because they have distinctly different capacities. So a dipole, that is traditionally a magnet, it has a liability in comparison as something that can cause effects. It has the liability of being a 50-50 mechanism, in the sense that it is creating both forces in the same proportion. And the only advantage it has is up close, it'll only produce that force in two distinct planes. So one side and the other side, but there's this whole mixed zone where the forces do get mixed and where the force is diluted. Essentially the segregation is diluted and it reverts back to just 50-50 or neutral. So magnets have a certain neutral component, especially at a distance. They can, because of the blending of the two, they can appear not as to be neutral rather than a magnet. Now the ends are probably a little bit different, where the force stays a little cleaner coming out of the ends of the magnet, but it still is dissipating. It's still diverging at the inverse square law rule. Alright, so that's I think the important mechanism to understand. So it's this size difference that makes charge. So when the atom is at the ground state, it's the middle size. When it's positively charged, it's been expanded, and when it's negatively charged, it's been compressed. So the electrons are closer together and contain, you can sort of obviously understand, more pressure between them because they have force bouncing between them. And as they compress, that force bounces more often. That's pressure. And when atoms, okay, so I guess I can flip it over and do some more. So what we call electricity is when two atoms of different pressures, or even the same pressure, but we'll use different pressures, interact. What they're going to do, either through an electron that, say, is bouncing between them, so there can be an electron trapped between the electrons that are attached to the atom. So these electrons are attached to the atom in the sense they're in very stable positions, created by the strength of the protons, attraction, and the repulsion of the electrons. It's a balanced amount of energy, and it keeps all the little charged components in a kind of tension. They can't move closer one way because that causes more pressure with the electrons. They can't move out because they are attracted to the proton, so they're kind of locked in a position. And so when the two atoms of a little bit different pressure interact, they hit each other, or this little electron bounces between them, what essentially happens is they share their pressure, and the two atoms will neutralize to a common pressure between them. Not necessarily ground, but just something average of the two. So if this was a 5 pressure, well, let's make it a 3 just for, oh, this is a high pressure. Let's make this a 10, and let's make this a 5. So there's two atoms going to interact at 5 and 10 is pressure. Then both of them, after they hit, or after this electron bounces between them and kind of incurs the pressure from one, it bounces harder off the higher pressure into this one and pressurizes it, gives it the energy. So they share the energy, and they basically average out their pressures. so that they become to 7.5 pressure. Now ground still might be 5, so they might still be above ground, above the ground state in terms of their pressurization, so we'd still call them like -2 or something as a charge. And this one would have been a -7 or something, and this one would have been a -5 or whatever. And so they're getting and it just keeps happening. Atoms keep hitting each other with different levels of pressure, and they all equal out. Now conductors do that really rapidly. All the atoms communicate regularly and easily, so they're close together, or the electrons are bound by a lot of these little free electrons that bounce between the atoms to exchange pressure. So a conductor can exchange pressure very rapidly, and through that process it creates the so I have to get to the movement of the charge and how this change in pressure is essentially what causes dipoles. So you can sort of understand that for them to be exchanging some sort of uneven pressure, they have to have uneven pressure. So it is, in a sense, the fact that two atoms would come in contact that have a different pressure is essentially creating a kind of magnet. So every time there's two atoms in a system that are, of different pressure, draw it exaggerated. I should draw it with this one red to illustrate. The more expanded is the proton heavy one, and the smaller one is the electron heavy, so it's the plus and minus force. So every time they're in contact with each other or near each other, so every time there's pressure to be exchanged, an unevenness in pressure, you're automatically creating dipoles. And dipoles are little magnets. And so the only issue is how, if you can create those in a sequence, then you're creating a magnet. So the more of them you have in sequence, the more magnetic the material will become in the process of just doing these exchanges, just having unevennesses in pressure. And you can sort of understand that as pressure would migrate through or cascade through a conductor, that there might be lots of circumstances like that where you'd end up with a high pressure and then it's pass at low pressure, and a high pressure would be passing its pressure from one to the next to the next to the next to the next, and you might be able to realize that there could be essentially an order that would be the red black red black red black, which is creating a magnet. So the pieces of the dipole, the dipole, the monopoles become in a sense atoms. Atoms are can be monopoles of magnetism. That is, a high pressure atom is the positive charge, and the low pressure, the small atom, is the negative charge, the compressed atom. And those charges can become dipoles under certain circumstances, like when current's flowing, and then that becomes filtered energy, and the gravity force goes through, and more as it goes through the system, more of it will be converted into black or red depending on the pressure of the atom. So as an atom pressurizes, the point is it excretes, so it gets energy, comes through it, comes into it mixed, a pressurized atom, from all directions. The energy is coming in from gravity, from the universe, as 50-50, and effectively it will come out of this. This is the, well, this was a neutron. This was a less high one, so let's just say this is we said it's a -2. So it's electron heavy, so it's a little compressed still. And so it'll now it'll convert that 50-50 into something, 60-40 in terms of percentages. And so it'll have a higher bias of black force, which will make it very reflective to other small high pressure atoms. So the whole plus minus sign thing being backwards and everything does make this confusing, but it's another subject where actually Benjamin Franklin did have it right, and they're confusing current. So the conventional physics says the current moves one way and the voltage moves another way. So they use plus and minus to designate, high voltage or high pressure. And so that's obviously wrong, because it's the electron that has the higher pressure. The negative force is the higher pressure force. But in a circumstance where you put an actual conductor or something in a field, it will actually pressurize in reverse. That is, if this pen was a piece of metal, and we imagine that way, okay, was a source of high voltage, and I put this pen into that high voltage field, logic says this end gets pressurized more because it's in the higher, it's closer, and at the inverse square law, this voltage will be much lower than this voltage. But the trick is much like on Earth. We're getting hit by gravity on the strongest amount of gravity that you can have on the surface. And above us is less gravity, and below us is technically less gravity. But the trick is, below us is being pressurized by everything above it. And the same thing happens to that conductor when I shove it into that electric field. Just like in water, like if you go into 40 or 50 feet of water, the water pressure is really high. It'll break your eardrums. And what's happening is essentially the push here is felt even greater here. So this end is the end that really gets pressurized, because the pressure moves in the direction of the pushing, and it gets greater as you go further through. So this ends up being the expanded space, because all the density of the electrons are moving that way. And so it really just becomes a density argument. How many, you don't have any new electrons to use. All you have are the ones in the substance. So for these to get more pressurized at this end, these have to get less pressurized. That is, as you push the electrons this way, you create space here for these electrons to expand into. So these atoms become low pressure atoms. They expand to become positives, and these are the ones that become negative. So even though the field says there's higher voltage here, the higher voltage ends up at this end. And so then when you actually start releasing the voltage, this is the end you're actually releasing the high voltage from, and the current is moving in the direction from the high voltage is escaping, and it's pulling more empty space, which is asking for more pressure, which makes low pressure to high pressure. The pressure is always going to move. The atoms are always just randomly banging into each other, and whichever one's high and whichever one's low, doesn't really matter what side they're on or where they are, the pressure is always just going to equalize as it moves. It's going to reduce to a lower average constantly. So in a sense, it has to go from high to low, because it's always averaging between the two. So any averaging has to be a lower average than the highest one. So it always is technically moving from high to low. But anyway, so it's really important to understand that. So the other catch to that is, so once I push this conductor into that field, I turn into a monopole, because it'll have more electrons, more density here, more compressed atoms. The atoms are more compressed here, just like being underwater. They're under more pressure. And the atoms here are under less pressure. And then if I break this, I'll trap this low average atoms in this new object, because they're all from very low to low here, and they're from medium to high here. So when I break it, I've created something that's automatically going to be low and something automatically going to be high in terms of pressure. So I've created a plus and a minus. A minus and a plus. But anyway, charged objects. And as long as I extract them from this field, that's what they are. I mean, once I break it, I've trapped essentially the pressure, the electrons, and they can't undo the fact that essentially more of them by a small bias in one end than are in the other end. So one end has to go high and one end has to go low. Yeah. And so I've created those monopoles of charge or magnetism. I've created two objects that now will radiate a different force. When the force goes into them, they'll filter it differently. The high pressure atoms will produce more electron force, and they'll reflect more electron force, and the low pressure atoms will reflect the proton force, and more importantly be attracted because of the absence of pressure with the negative force. So the thing producing a lot of electron force and very little red force, the proton force, they'll move towards, because they're not going to feel that pressure. They only got 20% pressure versus gravity's 50%. So you've turned the pressure of gravity that was 50-50 and you've reverted it to 20. And so you've changed the pressure, and just like with water or wind, you change the pressure and the thing's going to move into the low pressure. Right. So what else is missing? So a current moving through a wire might be something to get to, but the current can only move through the wire. Well, so another point would be is that the charge is usually just a surface phenomenon, the surface atom. So it'll be complete or 100%. So there's always some percentage of the original force that gets through. It's only some percentage that you're filtering, so it's only a bias in a direction. It's not like you can have a perfect charge where you block 100% of the red force and excrete 100% of the dark force. But the higher you do, the more efficiently you do that, the stronger the charge is, and the stronger your magnet is. Yeah, so I really already did the fact that the electricity travels just by, it's just really transferring pressure. And so when you do that, when you have a high pressure atom at one end, so you have a bunch of high pressure atoms, let's say, in an area. So yeah, I wanted to get to the fact that so when you put something in a field of high voltage, the thing polarizes in the sense that it pushes electrons and it creates empty space, and then sort of the movement stops. It can't do anything else. So once it pushes and creates the high pressure, and once it creates the low pressure, nothing else can happen until you change it somehow. So all the individual there's no current moving through it. There's no, and so like with a Venn diagram or something in an oxygen, in our regular atmosphere, some current can start to move because it'll go through the atoms, the pressure. So other atoms will pressurize and create a pressure differential, because now this has become the low pressure end, right? So by pushing the atoms with the Venn diagram, you create a low pressure end, and if you don't provide a source of something else to exchange pressure with, these atoms can't do any more exchanges. So they need atoms to do exchanges with, and the first ones they need would be at the ground end. They need to exchange with low pressure atoms. So the only other atoms are high pressure. They can't do anything with those until they create some, they get rid of the high pressure they already have. So they have to make a path to ground. So that's sort of what the Venn diagram does. You know, the more you point if you had a fluorescent bulb and you point it towards ground, you're going to get more light than if you leave it inverted. And if you put your finger at the end, you'll certainly create a perfect conductor to ground. This end of the conductor won't be perfect, so you won't be able to have much volume of exchanges, but they'll have a wide open conductor essentially for any pressure exchanges going down. So this will become very low pressure again because the ground will suck it out, and now high pressure can move back through this wire from the electric field itself. But it needs the electrons. It needs you to provide atoms that have the high pressure to pressurize these electrons. So you need the electrons to pressurize the electrons. But the electrons won't really be moving through anything. It's just the pressure. But you need a source of pressure to change the pressure. I hope I said that well enough. So once everything stops moving, the polarization stops because all the atoms try to become, well, no, because they're overall neutral. And all they've done is change proportion. So they've taken some percentage of the substance and made it high pressure and the other part low pressure, but the whole thing has to still remain the same amount of forces coming out, red and black, of the overall substance. So you created the dipole, which means you created half high pressure and half low pressure, but at a distance those two would equal neutral. So you still essentially have neutrality, and it's not until you add new pressure, and atoms with electrons that you can add new pressure through, that you can repressurize those atoms and start changing their size again, which will change their polar activity. The fact that they keep changing the orientation of the magnets, so to speak, and create a magnetic field that way. Yeah, well, I have to explain that a little better. Because you can do it with the atoms being misshapen, bent a little bit by the process. The electrons are pushed to one end of the atom, and that creates an atom with that creates a dipole atom. But I think you can also explain it by just keeping the atoms the same structure and just recognizing that you can create two atoms that are a dipole. So in theory, the atom can be a dipole, and that can have a plus and minus end. Two atoms next to each other can be a dipole, that is, one's high pressure, one's low pressure. And clearly a whole substance can be a dipole in that you have more low pressure atoms on one side and high pressure atoms on the other side. So it's just really about creating those dipoles and then combining them all, having some kind of common orientation to increase the field effect, which is all the same energy. It's just the force radiating in different percentages, and that's it. That's the only thing affecting, and it's creating the charged monopoles, and they're the ones disproportionately filtering the force, and how you arrange those create things that you would call a dipole or a magnet, and how you arrange magnets can create more and more magnetism. But it's all just one force, and the mechanism that makes the most difference is the idea that when the atom is pressurized, it becomes a electron strong filter. When the atom's depressurized, it becomes an electron weak filter, you could say, or a proton strong filter. The protons really aren't players in this electrical component. It really is all about the pressure of the electrons. So you could just say electron weak and electron strong. Highly reflective of the force, not so reflective. And that's the origin of the pressure, which creates the voltage, which is everything. So anyway, I think that's enough of an effort. Obviously all this stuff is a little nuanced. There's probably a perfect way to go through it or order all the, you know, the explanations, and I'll certainly work on providing that. I have written up a few of the principles, but yeah, it's like there's enough complexity that there's a right way and a wrong way to do this. So I'm basically arguing there's just the one force, magnoelectric, electromagnet, whatever you want to call it. It's just one kind of force. These little bits, and they're charged. They have a plus and a minus, two varieties, just like the matter bits have two varieties, and that creates all the effects, that one force. And the one force really is just gravity filtered. So this unifies all the forces. So electron pressure polarizes atoms, that is, it compresses the electrons. So when you're hit by more black force, so if the environment is pushing more black force, the electrons in an atom see more force from the outside, and they pressurize, just like you would feel more gravity. So if I made if you were an electron and I made more black force in gravity, it wasn't 50-50, it was 70-40, you would be pushed like there was more gravity. And the same thing happens to the atoms. They feel that extra pressure, they compress, and the electrons trap that pressure between them. Right, electron pressure polarizes atoms while it is quickly moving from atom to atom. And so the pressure moves from atom to atom, and it moves kind of quickly because the electrons just do this. I mean, they just push, and the little force bit that's trapped between the electrons. So each electron in the atom has bits that are keeping the electrons apart, keeping them repulsive. And so the pressure moves a little bit. That creates closer paddles, ping pong paddles, more pressure between the electrons. And then this one pushes that onto the next one, and the next one is just a cascade of that pressure. But most of the movement is at the speed of light, because most of the movement happens, the force bit is carrying the information most of the time. So only 1% of the time is electrons moving, and 99% of the time it's the force bit pushing, moving, and that's moving at the speed of light. That's why electricity is almost as fast as the speed of light. Can be very fast, is because most of it's happening, most of it's carried by the force bits. The electrons are just mediators. They just allow it to move from one to the next. Alright, the pressure is linearly polar until isolated. So that's the dipole argument. You put something into an electric field or magnetic field, and it will charge linearly, and just like the water, the high pressure of the water is at the bottom, the low pressure is at the top. It'll do the same thing. And if you separate those two bodies of water, they would average to very different numbers. So if you isolate it, then you've captured a change in pressure. And if you drain it into a pressure sink like ground, then all the pressure is going to tend to neutralize to that ground. The ground will take over. The average state will be the dominant pressure, unless you keep feeding voltage in. Right, isolated pressure creates magnetic monopoles of charge. So if you charge a balloon or you charge some object, you're basically creating a magnetic monopole, but the magnetism is only on the surface, so it doesn't have much density, but it's still substantial. A magnet from a distance is just a neutral gravitational body. So that's the catch of a magnet, is from, at least the magnet in this direction, is diluted with distance. The further away you get, the less you see the black and the red, and you just see mush, brown. The pressure is linear like water pressure. I said place with less causing pressure has more pressure. Right, so the place, again, so if you put something in an electric field, your intuition says the thing in the stronger field gets higher pressure, but it's like water. The high pressure is cascades to the other end, and the other end ends up being the higher pressure in the end, or in the beginning, if you want to look at it. Okay, so I think that's enough for this edition, and so I will attempt to clarify as I realize something wasn't said quite right, or this or that, or if you have any questions or something else, then I will elaborate more. But I mean, the basic idea I think is solid in understanding that there is this phenomenon in the structure of atoms where, as a practical matter, the electron does, to some extent, block the proton from a distance. And if the proton's radiating something different than the electron's radiating, you could sort of understand that that's going to change the percentage of what kind of radiation you see. Black radiation or red radiation is going to be completely dependent on how big the electrons are relative to the nucleus, or how close they are to its surface. That would change what you see. And that's essentially how that's essentially the difference between something positively charged and something negatively charged, is how much of the nucleus you can see. It's kind of that simple. Alright, so enough of a video, I think. So till the next time and such.